Bismillahirrahmanirrahim. Welcome to Applied Thermodynamics by McConkey with Dr. Abid Hussain. In this lecture, we are solving problem 4.14. So, problem is at the start of the compression process and the reciprocating compressor of a refrigeration plant, the refrigerant is at 1.5 bar and dry saturated. First, I write given data. So, in given data, initially pressure is 1.5 bar, P1 is equal to 1.5 bar, and initially refrigerant is dry saturated. Initially working fluid is refrigerant. Initially refrigerant is dry saturated. Initially refrigerant is dry saturated. So at the end of the compression process, which is according to reversible polytropic law, PV1.2 is equal to constant. So process is reversible polytropic compression according to a law PV1.2 is equal to constant. This is polytropic law. And the pressure is after compression pressure increases, so P2 is equal to 6.5 bar. Using the property of refrigerant given in table 4.3, this is table 4.3. So we will use this table, interpolating where necessary. Calculate number 1 required is number 1 change of specific entropy during the process is 2 minus S1, and number 2 the degree of superheat, degree of superheat, degree of superheat. So first we will use table 4.3, and first we find S2 minus S1, solution of part number 1. So we can as we know that initially the steam is dry saturated. Initially the steam is dry saturated. So this is temperature and this is entropy. This is some like the refrigerant curve, and P1 is 1.5 bar, so this is P1 is equal to 1.5 bar. This is the saturation curve for steam, but for refrigerant will be something like this, and this is P2. P2 will be equal to 6.5 bar, which is given to us. Now initially this is initial form. Initially it is dry saturated. Dry saturated mean that will be unsaturated vapor line. So this is font 1. This is saturated vapor curve. So initial font will be here. Final font is degree of superheat is required. It means that final font will be in superheated region. But we can also find this font if we found V2. So if we found V2, we can exactly say that this is in superheated region, and from superheated as degree of superheat is required, so from this we also concluded that second font will be in superheated region here, something here. So this is polytropic process, PV 1.2 is equal to C. Now from table 4.3, from table 4.3, at pressure is equal to 1.5 bar, pressure is equal to 1.5 bar, S1 is equal to and V1. We can find S1 and V1 from table. This is table at 1.5 bar. S1 is equal to Sg. S1 is equal to Sg because it is initially the steam is dry saturated. So S1 is equal to Sg is equal to 1.12 kilojoule per kilogram per Kelvin, and V1 is equal to 0.109. 0.109. V1 is equal to Vg is equal to 0.109 kilo meter cube per kg. Meter cube per kg. Now, for it is clear that it is superheated region, but if we further clarify this, so here we find V2. So as P1 V1 power 1.2 is equal to polytropic process P2 V2 power 1.2. So V2 power 1.2, rearrange this equation, divided by V1 power 1.2 is equal to P1 divided by P2. So this implies that V2 divided by V1 whole power 1.2. V2 divided by V1 whole power 1.2 is equal to P1 divided by P2. Or we have to find V2, so take 1 divided by 1.2, 1 divided by 1.2 in power. So V2 divided by V1 1.2 whole 1 divided by 1.2 and P1 divided by P2 whole divided by 1.2. So this one will be cancel with 1.2. So V2 divided by V1, or V2 is equal to V1 into P1 divided by P2 whole power 1.2. So this implies that V2 is equal to, the value of V1 is 0.109 meter cube per kg, and P1 is 1.5 bar and P2 is 6.5 bar. Whole power 1 divided by 1.2, and 1 divided by 1.2 is equal to 0.833. This bar will be cancelled with this bar. So V2 is equal to 1.5 divided by 6.5, then take power after division, take power 0.833 and multiply by 0.109. So the final answer of V2 will be 0.032 meter cube per kg. Now if we check in table V2, V2 is 0.027, from table Vg is 0.027 and V2 calculated as 0.032, more than Vg is from table 4.3 at pressure is equal to, at P2 is equal to 6.5 bar, V2 is equal to 0.027 meter. This is Vg. Vg is equal to meter 0.027 meter cube per kg, as V2 is greater than Vg. V2 is greater than Vg. So the refrigerant after compression is in superheated region. This point is confirmed. This is in superheated region. This is Vg. This is Vg. Vg is equal to 0.027 meter cube per kg, and V2 is 0.032, more than Vg. So this point will be beyond Vg and will be in superheated region. So this is point 2, which is confirmed. Now for S2. So at pressure is equal to, from using table 4.3, P2 is equal to 1.5 bar and volume meter cube per kg available in table is 0.030 meter cube per kg and 0.034 is available. but 0.032 is not available. So we will do interpolation. Entropy kilojoule per kilogram per Kelvin. At, at the front of 0.0 at pressure of 6.5 bar and volume of 0.030. Entropy is 1.15 and in front of 0.034 entropy is 1.21 and 0.032 is unavailable in the table. So we will do interpolation for it. In front of 0.030 entropy is 1.15, 0.03 is not available, so we will do interpolation. And in front of 0.034 entropy is 1.21 kilojoule per kg. So the method of entropy is interpolation is third minus first divided by third minus second. 0.034 minus 0.030 divided by third minus second is equal to third minus first divided by third minus second. 1.21 minus 1.15 divided by 1.21 minus S2. So 0.034 minus 0.030 is equal to 0.004 and 0.034 minus 0.032 is equal to 0.002. 1.21 minus 1.15 is equal to 0.06 divided by 1.21 minus S2. So this implies that 0.004 divided by 0.002 is equal to 2 is equal to 0.06 divided by 1.21 minus S2. Cross multiply, so 2 into 1.21 minus S2 is equal to 0.06. So this implies that 1.21 minus S2 is equal to both sides divided by 2. So 0.06 divided by 2 is equal to 0.03. Now 1.21 0.0 on other side will be minus, and this is minus S2, so on other side S will be plus S2. So S2 is equal to 1.21 minus 0.03 is equal to 1.18 kilojoule per kilogram per Kelvin. Now change in entropy, S2 minus S1 is equal to S2 is 1.18 kilojoule per kilogram per Kelvin and S1 is equal to 1.12 kilojoule per kilogram per Kelvin. So change in entropy is 0.06 kilojoule per kilogram per Kelvin, and positive sign mean that entropy increases. Now we found part 2, degree of superheat. So degree of superheat is equal to T2 minus T2S. It means that given temperature at T2 in superheated region and saturation temperature at T2. This is TS diagram. Temperature degree centigrade and entropy and kilojoule per kilogram per Kelvin. This is something like saturation curve. This is P1, this is P2. Initial font 1 is here, final font is here in the, this is T2, here T2, this is T2 and this is T2S. So difference of temperature between T2 and T2S, this is called degree of superheat. So we will find T2S and T2. So from table 4.3, at pressure is equal to 6.5 bar, P2 is equal to 6.5 bar, T2S is equal to 35 degrees centigrade, 25 degrees centigrade, and for T2 For T2 we will do interpolation because 6 because volume 0.032 is not available. So from table at P2 is equal to 6.5 bar, at P2 is equal to 6.5 bar, specific volume 0.030 meter cube per kg and 0.034 is available, and in front of 0.030 temperature is 50 degrees centigrade and table 4.3, check this, and at 0.034 temperature is 70 degrees centigrade, but we have to find temperature at 0.032 which is unknown to us. I gave name T2. So we will do interpolation. So third minus first divided by third minus second is equal to 70 minus 50 divided by 70 minus T2. Third minus first divided by third minus second. So already solve this. Answer of this is 2. 70 minus 50 is equal to 20 divided by 70 minus T2. So this implies that cross multiply 2 into 70 minus T2 is equal to 20. Both sides divided by 2. So this implies that 70 minus T2 is equal to 10, and 70 minus 10, rearrange this equation, is equal to T2. So T2 is equal to 60 degrees centigrade. Now degree of superheat is equal to T2 minus T2s. So which is equal to 60, T2 is 60 degrees centigrade and T2s is equal to 25 degrees centigrade. So the answer is 35 degrees. Degree of superheat is 35 degrees centigrade. Note that in the book the answer is 35 Kelvin. So both are same. In the book answer is 35 Kelvin, but both are same because if we convert this degree centigrade into Kelvin, so T2 is equal to 60 degrees centigrade is equal to 60 plus 273 Kelvin, so which is equal to 3 plus 0 3, 7 plus 6 13, and 3, 2 plus 1 3, 330 Kelvin, and T2 is equal to 25 degrees centigrade, which is equal to 25 plus 273 Kelvin, which is equal to 293. This is 25. This is 25. 2. I think it is wrong. 0 plus 3 3. 7 plus 6 13. 1 plus 6. This is wrong. 3 plus 0 3. 7 plus 6 13. 1 plus 2 3. 333 Kelvin. And 3 plus 5 8. 3 plus 5 8. Our 7 plus 2 9 and 2 298 Kelvin. So degree of superheat is equal to T2 minus T2s. So 333 Kelvin, 333 Kelvin minus 298 Kelvin, which is equal to 35 Kelvin. So note that 35 degrees centigrade is equal to 35 Kelvin. And the problem is completed. And for more lectures and problems, please like and subscribe my YouTube channel and share with your friends. Thank you.